Okay, so this is the slide. If you don't really want to watch, you don't have to. I'm going to prove the mean value theorem. And it's kind of neat how this develops. Here's my function f that's going to be continuous and differentiable. Okay, so f is continuous on the closed interval ab, and I have a and b labeled there for you. And f is differentiable on the open interval ab. So not at the endpoints, but everywhere in between you're good. Okay, so we know what we need to prove. It's the end of that song, but how are we going to get there? Okay, so first of all, I'm going to go ahead and draw the secant line that connects point A and point B. Okay, so there we go. I'll even go through point A and point B. So it's not a line segment, it's actually a line. And I'm going to call that function g. Okay, and we're going to construct a function here. We're going to create a function called h, and h will be equal to f of x minus g of x. Okay, in other words, the y value of f minus the y value of g is what this function h is doing. Now, there's a couple things to notice, okay? This is a, right, and this is b, our interval, and h of a is equal to 0. Why? Because that's where the graph of g and the graph of f intersect. So when you subtract their y values, you get 0. And you know that h of b is also equal to 0. Same reason. Both graphs intersect there, so their y values will cancel out. Now, by Raleigh's theorem, okay, we have a function that has the same y value at two different points. And Raleigh's theorem says if that's the case, then somewhere in between those 2 points, there is a value of c where the derivative of the function is equal to 0. So in our case, h prime of c will equal 0 for some value of c on the interval ab. So somewhere in here, between a and b, there's a c where this is true. Okay. So what is h primed of c going to be? Well, let's take a look. H primed of x is going to be equal to f primed of x minus g primed of x. And the theorem says that h primed of c will be f primed of c minus g primed of c. The theorem says that this number has to be 0 at that spot. Okay, so I have 0 equals f primed of this mysterious number minus g primed of this mysterious number. If I move the g primed over, I have a equation here, and I'm almost to the end. And the key here is that, remember, g is a line, and g primed is the slope of the curve, in this case the slope of a line, which is always the same no matter what. So what is the slope of this line? Well, guess what? It's f of b minus f of a over b minus a. Okay, so that number has to be equal to f primed of this mysterious number that we may or may not be able to find, but that number has to exist.